Hi, welcome to Module 6, Fatigue. I don't mean the usual kind of fatigue that might make you sleepy as you're trying to go through the semester here, but specifically fatigue of materials. Here we're talking about cyclic loading of materials and what happens when you load a material over and over again at loads that are well below the yield strength of the material, but because of the repetitive loading can still cause failure. You've all been introduced to the subject of fatigue in your undergraduate classes, and we're going to take it a little further this semester. This is another module like fracture mechanics that we could spend a whole semester studying fatigue. And in fact, if you were a material science graduate student, you might spend a whole semester just studying fatigue. What we're going to try and do is bring in some of the important advanced concepts that you didn't get in your introduction to material science class, and again, focus on the material aspects of fatigue. How is it different in metals than it is in polymers than it is in ceramics? We'll start out by looking at the statistical nature of fatigue. Unlike many of our other static failure criteria, statistics becomes important to fatigue because of the somewhat random nature of the processes that happen within the material. We'll describe the different phases of the fatigue failure process, and we'll talk a little bit about the test methods that are used to estimate fatigue behavior, because this is one of the challenges with design, that if we're designing something that has to last for 10 million cycles or 10 years, we can't run a laboratory test for 10 years. So we have to find ways to accelerate the testing methods that will map to the real service life. We'll look at the unique mechanisms for metals versus polymers and ceramics and how to interpret the data from fatigue testing. And then we'll look at a few cases of applying advanced analysis rules to the design of fatigue that are based on monotonic criteria like yield strength and tensile strength. And we'll even look at fracture mechanics from Module 2, but this time in the fatigue scenario, and what happens when you have a stress intensity ahead of a crack, but you have a fluctuating stress intensity because the load is going up and down and up and down. In the end, hopefully you'll appreciate the design trade-offs between fatigue and service conditions and monotonic loading, and have an appreciation of how to design under these complex situations.